Okay, so what I was just saying was when you go to punch this in your calculator, don't forget to square this 0.21 up here on the top. And then it's all divided by 0.21. And no, you can't cancel out a delta t because there's no delta t in this first term with delta d. So when you carefully punch this in your calculator, you should get 5.3985 meters per second. And so that becomes the VF of the window piece. So we'll have the VF, the VI, the A, and we want the delta D. So now, second does not spell first. You would use VF squared is equal to VI squared plus 2A delta D. And if you were wondering why I wrote first when I said second, because I was thinking, oh, I didn't write first up there. All right, and so we're solving this time for delta D. So subtract VI from both sides and divide by 2A. And the VI is actually 0. So the VF is what you just found, the 5.3985, with the rest of its units that are in your calculator. So don't clear it, just square it, and then divide by 2 times 9.81 meters per second squared. And when you do that, you should get a delta D of 1.4854 meters. Okay? Which is the height of above which it was dropped. Okay, so those were all your homework questions from day 1. The other piece, if we were in school, that we would have talked about in the last 2 days was this sheet of paper about how to write up a lab based on the lab that we did when we were last together. And some of you haven't done it yet, but when we get back together, you can do it. But I'd just like to go through this because this is how you will always write up a lab for me, and when you go to university, it's how you will write up a lab there. This top piece is really just the front page. I just didn't want to waste a whole sheet of paper. So on the front on a blank piece of paper, you would put the lab title in like the middle of the page, and then these two parts would be down at the bottom. And it would just be your name and then your partner's name and physics 11, 2, and then over here the date the lab was conducted and my name. Okay, and then this stuff goes inside the report. So this is your cover page up here. So inside the report, the purpose, which is the statement or goal, and I've given it to you. You can just copy it exactly from the lab. Okay, your hypothesis, it's your prediction based on knowledge, past experience, intuition, etc. And I had you write that before you started the lab. So you would use the first line as I gave it to you in the lab, and then when it goes ... elaborate, then you would write your prediction that you thought which of the three of them would have the biggest acceleration and which of the three of them would have the smallest. And like I said to you in class, it does not matter if you're right or not. It'll give you something to talk about in your conclusion. The next part on how to write up the lab is your materials, and you can just list them exactly how they're listed because everything that we used is there. Okay, it's the procedure that's usually the tricky piece. The procedure says a step-by-step chronological listing of what was done, written in the past tense and impersonal. Okay, so you can't just take your procedure and put an ED on every verb you see because it's not going to be proper English. You actually have to change the words around because these are command statements and you can't have past tense command statements. So what I mean by that is like sentence 1 says, gather all materials and proceed to the upper level of the cafeteria. You wouldn't just say gathered all the materials. You would say all the materials were gathered. So all the materials becomes your subject, and to figure out what your subject is, because in sentences you need subjects or else your English teachers will go gray before their time. So to figure out what the subject becomes, ask who or what after the verb. So say gathered who, gathered what. The answer is your subject. Gathered what? All the materials. So the sentence becomes all the materials were gathered. And so you can't just say proceeded. You have to say what was, you would have to say and taken, maybe, because the materials didn't proceed on their own, and you can't say we took them. So all the materials were gathered and they were taken to the upper level of the cafetorium. Next sentence. Using the measuring tape, measure the vertical distance from the dropping point on the upper level of the cafetorium to the floor. So again, you can't just put an ED here. So what was measured? The vertical distance from the dropping point on the upper level of the cafetorium to the floor was measured using the measuring tape. Next sentence. Be sure to keep the dropping area the same for the entire experiment. You could say, it was ensured that the dropping area was kept the same, or just the dropping area was kept the same for the entire experiment. Record this under delta D in the data table. So you could say, record this, record what? The measurement that you just took. So the measurement was recorded under delta D in the data table. Okay, the next one's tricky because it says, have a partner go to the cafetorium floor, and you can't have a person. Have the partner go to the cafetorium floor with a stopwatch. So you could just say the stopwatch was taken to the cafetorium floor. Doesn't matter who took it, it matters that it went there. So the stopwatch was taken to the cafetorium floor and used to measure the time it took for the first object to hit the floor after it was released. Instead of saying have the partners record it, you could say this was recorded for the time under the object under trial 1. Okay, so do you see how you can leave out people and you can make it past tense? The experiment was repeated for the other 2 objects. The times were recorded. Then it says have the partner on the floor gather the 3 objects and return them upstairs. So you could just say the 3 objects were gathered and returned upstairs. And then you would say it was decided. Instead of decide if one partner will drop or you'll switch, just say it was decided if the jobs would remain the same. And then tell me what you did specifically for your lab. So you could say it was decided that the jobs would stay the same instead of being switched, or you could say it was decided the jobs would be switched instead of staying the same. Okay, and then steps 3 and 4 were repeated 3 more times, 8 more times, however many more times you did. Once the trials were recorded, all 3 objects were collected and items returned. Okay, so that's the procedure. For the questions, hopefully you know why it was necessary to repeat more than multiple times for each object. Show the calculations. Okay, so to show the calculations, you're going to use delta D is equal to VI delta T 1/2 A delta T squared. The VI should be 0 because you're dropping it and you're solving for A. So the lab has to be written up, but I don't mind if you show your calculations by hand and just hand them in on a piece of loose leaf attached to your lab. Okay, but the lab needs to be typed up, but I don't expect you to type up the calculations unless you are really bored on these days off. Okay, so in number 3, you're going to show, or number 2, you're going to show the calculations for the tennis ball, for the cork, and for the birdie using your average time, and you're going to solve for A, and your delta D's from the table should be what you got with your measuring tape. Okay, number 3 says compare them. Do they make sense? Do you see any trends? In the ideal world, you'd get all your acceleration due to gravity to be 9.81, but it's not really going to happen because I'm sure we made way too many mistakes while we were performing the experiment. So look at them. Is the one from the tennis ball biggest? Does that make sense? Maybe the cork or the birdie is tiniest. Does that make sense based on their size, their shape, and their mass? And then it says the theoretical value, you're going to do percentage error. And I showed you this at the beginning of the course. The equation for percentage error is the theoretical minus I think we called it the experimental. Theoretical value minus the experimental divided by the theoretical. And the theoretical is 9.81 meters per second squared. Oh, and then we're going to times it by 100. Going to run out of time here. These are called absolute value. signs. So if